Welcome to my class of computer graphics. Today we will learn about midpoint subdivision algorithm. Midpoint subdivision algorithm is an extension of Cyrus-Bake line clipping algorithm. This algorithm is mainly used to compute visible areas of line that are present in the viewport are of the sector or the image. It follows the principle of bisection method and works similarly to the Cyrus-Bake algorithm by bisecting the line into equal halves. But unlike the Cyrus-Bake algorithm, which only bisect the lines once, midpoint subdivision algorithm bisect the line numerous times. What are the important points or to be considered in case of midpoint subdivision algorithm? Also, the Sutherland-Cohen subdivision line clipping algorithm requires the calculation of the intersection of the line with the window edge. These calculations can be avoided by repeatedly subdividing the lines at the midpoint. Like other algorithm, initially the line is tested for visibility. If line is completely visible, it is drawn, and if it is completely invisible, it is rejected. If the line is partially visible, then it is subdivided into two equal parts. The visibility tests are then applied to each half. The subdivision process is repeated until we get completely visible and completely invisible line segments. Now, let me share the screen so that I can explain the midpoint subdivision algorithm in a better manner. If we look into this diagram, let me write here, let me write the algorithm name first so that it is clear. It is midpoint subdivision algorithm. So here we find that lines are of different type. One is completely outside the area of interest. Second is completely inside. And there are two conditions when the two lines are partially inside and partially outside. Let us look into the different steps of the algorithm. Let us look at step 1. What is step 1? Read two endpoints of the line P1 x1 comma y1 and P2 x2 comma y2. Second step, just look into second step is Step 2. What is step 2? Read two corners. What are the two corners? Left top and right bottom. Read two corners of the window. Say W X 1, WY1 and WX2, WY2. So these are the coordinates of the left top and right bottom. Third step. Step 3 is assign region codes for two region codes for two endpoints using following steps. What are those? Initialize code with bits 0000. Now we will say that set bit 1. Set bit 1 means the value of bit 1 will be 1. What is the condition? If x is less than wx1. Similarly, we will write set bit 2 if x less than wx2. Set bit 3. What is the value of bit 3? If y less than wy1. Next one is set bit 4 if y is greater than wy2. Then we can say that we can set the value of bit 4. Step 4 is here the checking for the visibility of line is done. Check for visibility of line. How to check for the visibility of line? If region codes for both endpoints, if region code for both endpoints are 0, then the line is completely visible. Then the line is completely visible. Hence, draw it. Region code for both point is for both point. Wait, let me do a correction. Now both points are 0, then the line is completely visible. Hence, the line is drawn. Hence, draw the line and go to step 6. B is if region codes for endpoints, if region codes for endpoints are not 0, what will happen if the region codes for the endpoints are not 0 and the logical ending of then is also non-zero? Then we can say that the line is completely invisible. Since the line is completely invisible, so reject the line. Hence, the line is rejected. And now, what is the third condition? If region codes for if the region codes for 2 endpoints do not satisfy the conditions, then what will happen? The line is partially visible. We can conclude that line is partially visible. In this case, the line is partially visible. So these are the condition. Also, if the region codes for 2 endpoint don't satisfy the conditions which is explained earlier, then also we can say that the line is completely invisible. So what is the next step? These are the sub steps of the line. The next step is stop. So these are the steps of midpoint subdivision line clipping algorithm. Now let me insert some shape so that I can explain better. Here, suppose a line is there. Here, a line is there, and we intercepts the point. This is one of the point, and here again this. So here, this is the point P1 and P2. Suppose this point is referred as P1. Similarly, here this point is referred as P2. So here there is P1 and here there is P2. So these are the point. So in this figure, we can say that the line is partially visible. In P1 and P2, it is partially invisible. So it is subdivided again in equal parts. How the subdivision is made? Let me explain this. Wait. This line will be divided into again a small point. Again, the line is subdivided into two equal points, and then the algorithm is worked upon. That means this point here also. Here this point is there. We have in the previous figure also point P1, it is at the same place. So this one is for point P2, and here we will define this as wait. So here the line is divided equally in further 2 points like P1, P2. Here the line is subdivided into smaller points, which we can name as P3. We can name it, we can name it as P3. Why it is called P3? Because the equal subdivisions are made. So P1, P2 is divided again into P1, P3 and then P2, P3. So this is the condition. So both the line segments are tested for visibility up to P1 to P3 and then P3 to P2. Again, they are subdivided into two equal parts. So it is observed that unless a region becomes completely invisible, it is not rejected. In this way, the midpoint subdivision algorithm works upon breaking the line or upon intersecting the line into two equal parts, and after subdividing it into smaller parts, again it is checked for the visibility. If it is completely invisible, then it is rejected, else the algorithm continues. So what are the advantages of midpoint subdivision line clipping? It is suitable for machines in which multiplication and division operation is not possible, because it can be performed by introducing clipping divides in hardware. This algorithm is mainly used to compute visible areas of line that are present in the viewport areas or the sector of the image. So, this is how the midpoint subdivision algorithm works. Now, this is the reference of the book. These are the book that I have followed for midpoint subdivision algorithm. Thank you for watching.